let's take a look at your CFU worksheet for chapter 1.4. My apologies on 1.3 if those of you looked at it. Here's finally where we start to look at the different graphs of quantitative data. So the first question here says, the following sample data set lists numbers of minutes of 20 internet subscribers spent on the internet during the most common session. Notice how we have numerical value, quantitative data. So here's the different minutes that people spent on the internet. So question A says, make a dot plot to display the data. So when I'm doing a dot plot again, we're going to have a number line. In our case here, a number line represents minutes online. So that's basically our title because we're just dealing with that as our one piece. If I look at this, we try to make it pretty simple, multiples of 5 minutes. Looks like the low goes from 15 all the way up to a high of 80. So I'm going to start at 15 and count by 5s. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So I want to put a dot for each of the different data points. So when I do this, I want to just kind of do a dot for each point. So as I'm doing this, 50, 40, 45, 35, 45, anytime right on top, 55, 25, 35, another 35, 50, 40, 15, 25, 40, 45, 50, 35, 40, 65, and 80. So now, got a picture of what our data starts to take a look like. So on B, it says, describe the overall pattern of the distribution and any deviations from that particular pattern, okay? So if I take a look here, okay, what I like to do is just kind of draw a curve over it, and we'll talk more about this as we continue on looking at the graphs, okay? And it looks like it's fairly balanced. So when we're looking at the pattern, it looks, what we would say fairly symmetric. The left side and the right side kind of look like each other, okay? And it looks like the middle is right around here, probably right around 40 minutes, okay? Or the center. So I'm just going to note that. So we would say here that it's roughly symmetric with a center around 40 minutes and since we can talk about the range, max minus min, and a range, since we're going to talk a little bit about the spread of the data, okay, a range of 65 minutes. Remember, range is max minus min, so 80 minus 15. Now it does says, describe any deviations, okay? We might want to say 15 and 80 minutes may be outliers. Whoops, I wrote may be outliers. Okay. Now if you only said 80, I'd probably be okay with that if you left off 15, because even when I look at 40, it's only 25 away versus 40 away. And then you might be arguing, well, why isn't 65? So there's parts of me with that 15 in there, should it be in there or not? There's parts of me that says, you know what, I'd almost, now rethinking of it, I might take that out. I might say 80 minutes may be an outlier. I'll rephrase it there, an outlier. Just because, 65 and 15 probably are a little bit closer. That's where Later on, we'll talk about how to mathematically justify an outlier. All right, number 2, like this one, says fuel efficiency. In an earlier example, we examined data on highway gas mileages for model year 2009 mid-sized car. Mainly it was done in another problem. The dot plot below shows the difference highway minus city in EPA mileage for each of the 24 car models from the earlier example. So this was an earlier example, I believe, from a problem in your book. You might even be assigned to do something from it. So in question A, it says, explain what the dot 6 represents. So the question is, what does that dot right there mean? Okay. So again, since it's talking about highway miles minus city miles, it's just basically saying the car gets on average 6 more miles per the gallon on the highway than it does on the city. Okay, so the 6 represents a car that gets, or that got, 6 miles per gallon more on the highway than it did in the city. All right, question B says, what does the graph tell us about fuel economy in the city versus highway for these models? It says be specific. So when it says be specific, you got to give some sort of numerical or some sort of specific examples that you are, looking at from the graph. So there's definitely several examples that you could talk about here when you're going to give specifics. But what's one of the biggest key things that this graph is showing? Well, it's showing, right, that all the cars in the graph did get better gas mileage on the highway than in the city. So I'm going to note that first. Okay? So let me move this up if I can just a little bit more. Makes it a little easier for me to write again. So all the cars get better gas mileage on the highway than in the city. Now I want to get specific. So if I take a look at this, okay, I want to mention something like, look at how well some of these cars do. Okay? There's a little gap here, but I still want to kind of include these. So what I'm going to do is look at that. All the cars but one are getting 6 or more miles to the gallon better. Okay? Or maybe, I might say something like that. All but one car gets at least 6 miles per gallon more on the highway than in the city. Now, is that the only thing you could say? You could have, instead 1, you could have gone to 7, okay? You could have said more than half the cars get 9 or better, okay? The key thing is you gotta look for something that's specific and that is supported, again, by your graph. All right, this ends page 1.